So, champions, well, welcome back to ArmanisMath. Today's lesson is about graph of the cosine function. So today we're going to graph the cosine function. Aren't you delighted? Good to see all of you here. You made the right decision. So let's get started. We always have a warm up for you. And the warm up today is going to be pretty simple. A little bit similar to last one where we graphed the sine function. This one is graphing the cosine function. So I wanted you to, as well as do, make sure you have, make sure you got your notebook ready and taking notes and stuff. The comments in YouTube Live is available. Same thing with the chat if you still want to use it in the other application that we're using. So either or, it doesn't matter. Just make sure that you give me some feedback as we go through the learning process. Okay, I am thrilled to have you again here. This is the 15th. Actually, this is our 5th week actually online. So I'm glad that you still hang around. And by the way, these videos and lectures and things are not available for everybody. So I would highly advise again that you would share. Please do subscribe. You know the drill, right? Like, subscribe. Do that. That helps me, keeps me motivated and do more, obviously, as I feel that you're benefiting from it. Anyways, back to the warm-up, and I always give a timer for the warm-up. And let's see if we could put a timer here for perhaps a couple minutes. Okay. And you know me, we're not going to wait for a couple minutes, but we have to pause halfway through almost. So if you're watching this afterwards, make sure that you pause and get yourself in the game by thinking about this. Okay. Let's get some background music here. Right, so I'm gonna pause here, and then get started. You could help me with the comments to give me some answers, so you don't have to wait for me. So anyways, cosine pi over 2. Pi over 2 is, what degree do you think we're talking about in degrees? What is pi over 2 in pi radians? Anybody tell me? Yes, I got that. So this is actually cosine 90. So they're asking us of cosine 90, and cosine 90 is, I forgot. Oh, but I still remember the unit circle. So cosine 90, I could use my unit circle for that, and graph myself a little circle, just a little tiny circle here. Okay, and then I'm gonna get myself a couple lines here. Obviously, I'm taking some time in the warm-up to, again, get us in the game, get our brains in the game and minds in the game. So at 90 I have 0, 1. So cosine would obviously mean the x part of it, which is the 0. So cosine 90 is 0. 0 is the value, by the way, it's not a degree. So cosine 90 is 0 in its value. Okay, cosine 30. Cosine 30 is, it is, if you guys remember, square 3 over 2. However, today I wanted to see this in decimals, so we're actually going to put that in, if you could, with using a calculator, if you could just give me a value down here for this cosine. I believe I'm almost close to 0.86. Okay, so but it's not 1, close to 1, but 0.86 is the cosine value. Graphing the x squared, obviously there's a reason we're asking for this, one of which is to condition our brain and the transformation that's going to happen in the graph today. So we are graphing some functions today that will be transformed. I need to change this color after the next one, but y squared is going to be vertex at 0, 0, and it looks like this. This vertex here is at 0, 0. Now what happens if you want to transform? If you want to transform, means you could translate, you could reflect, you could rotate, and this number 4 has to do with that. So number 4, I need to do some shifting of this vertex point here. So this vertex point now is going to move to the left 3 units, and it's going to move down 1 unit. So if I were to graph this, I will end up with something like, give myself my room here. I'm going to say I went to the left. Why to the left, Armani? I thought this is plus. Yes, remember this, in any function there's always minus h. I'm going to put that in red for you here. Minus h, or the horizontal shift. So it's built into the function to have this negative here. So you always do the opposite direction of what you see when it comes to the horizontal shift. Horizontal shift is the x-axis shift. You're shifting to the left or shifting to the right. And it's always the opposite direction of what your eyes see here next to the h. K, or the vertical shift up and down, that you just have to follow the sign. If it's negative, you go down. If it's positive, go up. Which is a K here. Okay, so anyways, I said I'm gonna have to go back 1 and 2. There's 1, 2, 3 dots here. Here's 3, and I have to go back down 1. So actually my function now, my quadratic would look like this. It's not drawn to scale, but something like that. Okay, your new vertex here, your new vertex, instead of 0, 0, your new vertex is gonna be 3, negative 3, comma, hold on, 3 comma negative 1, yes, negative 3 comma, okay, comma negative 1. Give me a thumbs up or say something, put something down in the chat that says that you got this, we're good. If not, I definitely could take more time, but I need you to respond because this is you taking the time and learning, so we want to make this beneficial to you as well. So all right, the objective today, we will be able to recognize and graph the cosine trigonometric function. So basically we're after the cosine today. We did sine last time, and I believe when we did sine, some of you, you were just having fun, I guess, because you traced the sine. Equally amusing is the cosine. So any word from in the comments, any word from the objective would help me. Any word from the objective would help me to know that you guys are with me. Okay, so just give me any word here. Choose a word from the objective and put that in the comment. I know there's a delay, so I'm gonna just pause a few seconds here. Yep, I see that. Which was that word? Pretty interesting indeed. Okay, similar to the sine graph, Where do you actually use this in life? We said last time that music, radio waves, and sound waves actually are composed. You could use the sine and cosine trig functions to model these kind of behaviors, okay? Especially music and sound waves and stuff. Can you think of another one? If you can, you could definitely use the comments to put your ideas there. Here's some vocabs. If you did last lecture with us, this should be a breeze for you. But if this is the first time you're seeing the law of cosine, the graph of cosine, it's not a big deal. I mean, you just have to go through the definitions here. The cosine is a periodic function, meaning it repeats itself. It's cyclical, so it repeats itself. Just like when you're watching for the Ferris wheel, for example, the Ferris wheel, and your eyes are gazed on a particular cart on the Ferris wheel, and it goes up and down, up and down. That's exactly the same. It's called periodic. It happens over and over and over again in intervals called cycles. It's cyclical, cycles. What is the period when you talk about the periodic function? Well, the period is the length of that cycle. Like, how long does it take? Does it take, let's say, 90 degrees to revolve and finish? Does it take 360 degrees, etc., etc.? Amplitude is how high can you go from the midpoint, and how low can you reach from the midpoint. So how high and how low can you reach from the midpoint? So if I'm just trying to graph an amplitude here, would basically be something like this. I have a midpoint, let's say like this, and how high can I go? How low can I reach? Something like that. So this is the amplitude would be from here to here, this distance here. See that distance? That's the amplitude. And it's always positive because it's distance. Distance is always positive. You can't walk 2 miles, you cannot walk negative 2 miles to the mall. It has to be positive. You cannot drive 5 or let's say 300 miles to LA, negative 300 miles to LA. You can't do that. It has to be positive. That's the same thing with amplitude. It's got to be positive. All right, and we are not really going to discuss this today, but in case if you had this appeared in the future, this is called the frequency. This is used a lot in electronics, obviously, and it just says the number of cycles in a given unit of time. So how many times do you see the oscillation, for example, for up, off and on, or zeros and ones? I studied computer engineering, so you just have to know how many times is this going to happen. And obviously, the more it happens, the more operations that the electronic device is performing, hence the better performance it has because of the more frequencies that it has, and it's measured in hertz. We're not going to discuss that today. And we're going to also wait for the phase shift. Phase shift is the horizontal translation, just like what we've done with the if you guys just remember a few minutes ago with the quadratic function, which we started here and then we shifted down here maybe or something. This is horizontal translation. We're not going to discuss that today, but keep that in mind because that is kind of a little bit down the road in terms of graphing the cosine. But what we have today is going to be sufficient. It's going to suffice what exactly the desire for us, which is to graph the basic cosine function. All right. So periodic and non-periodic. You have to know that periodic functions, again, they repeat themselves. They keep repeating. You put your clothes in the laundry and then you hear this coin that you forgot and clink, 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 clink. That's cyclical. It happens and happens and happens. As long as that drying your clothes, you just keep hearing the same clink. That same thing, periodic. It's periodic and it does repeat itself. So here's an example of periodic on the left side. This is a periodic function here because it does repeat itself. If you guys look, by the way, it doesn't matter where you start in periodic because it's going to repeat itself. So if you start here, you go down here and go up here. Then down here, see that? See, you start here, go down here. So I'm going to pause here actually. See that blue thing? Start here like this. Stop here, then you start here. And then you get repeat yourself again. Gonna start here, gonna start here. See that? This is called cyclical. It's periodic. It happens over and over and over again. So how do you measure the period? How do you measure how long it takes for that wave to start and finish? Well, you have to decide. Pick a point. Pick a point. Let's say I pick this point. That's my starting point here. So this is your ending point. This amount here is going to be the time that it takes, for the wave to start and finish. And you call this the period for that function. Okay, it doesn't matter where you start. You could actually start from here to here as well. See that? Okay, so that's the same thing, period. Now this obviously on the right side, this is not periodic. It does not repeat itself. Doesn't repeat itself. I don't see it repeating itself. It's non-periodic. Okay, here's the first example. It says identify if this function is periodic. And the second thing, if it's periodic, then give its period. How long does it take for the wave to start and finish? Well, first of all, is this periodic? Do I see this wave repeating itself over and over and over again? I do. Look closely. I do. I see it repeating itself. And no matter where you start, you just have to look closely. You're going to see it's repeating itself. Okay, so I have here, and I see it here. I mean, I do see it. If I looked here, for example, let's say I'm gonna start. Doesn't matter. I could start here. So I go up and down, and I go up here, stop here, and that's again. I could stop here and then go here. So from here to here. How long? Well, it's actually giving you a hint here. It tells you if you start at 0, you're going to end up with pi. Well, but you started a little bit before 0, to the left of 0. Okay, then you shift your pi to the left as well. So this portion here becomes your period. That's the period. That's how long it takes. And in this case, the period is pi. Like 180 degrees is how long does it take for this to start and finish. Okay, you also could start maybe somewhere else. It doesn't have to start here. You could start here at the top. Start at this top, for example, all the way to this top. So how long does it take to start and finish? Well, again, this is going to take you 1 pi. Okay, so it just depends on the function that you look at. Obviously, the sine function that we looked at last time, it has to have 2 pi radians, 360 degrees to start and finish the wave. We're going to discuss something very similar about the cosine today. So here, this pattern repeats itself exactly, and that's why it's periodic. And the second portion of the latter portion of the question here, identify the period. So the period takes 1 pi. As I said, you could, no matter how you slice it, beginning and ending point of the wave, you're going to end up with a pi. Okay, here we go. So now we are ready to get started thinking about the cosine function. How do I graph the cosine function? Okay? First thing first is I'm going to have to focus. I'm going to have to zoom in only on cosine. So I really have to keep my eyes on cosine. Okay? Because I want to graph the cosine function. So how do you keep your eyes on cosine? Well, you gotta go to your unit circle, your beautiful, attractive unit circle. Ooh. And you're gonna circle every cosine that you see. Every cosine value I see, I'm gonna circle that because that's gonna help me find some values. So at 30, I have a cosine of square root 3 over 2. I think we did this in the warm-up. Come on, you guys. What's the value for this? I mean, in decimal. It was this one here was 0.86, right? About that much. Yeah. Okay, and then actually, hold on, I skipped one. What's cosine of 0? Well, remember, cosine is the x part of your point, and the y part of your point is the sine. So what's cosine of 0? Well, here's a 1. So I'm going to circle 1. Go to your 30. Circle the cosine, which is square root 3 over 2. I put that value here, by the way. So, you could also do the 45. And how about this? You could do the 45. Plug that into the calculator and find out what's that in decimal. Excuse me. Now the 60 has a cosine of 1/2. That's a little bit friendly. So maybe it is exactly 0.5. There's no guessing here. Okay. Doesn't like that top. So 0.5. 0.5. Okay. And also, if you looked at, let's say, 90, what's cosine of 90? Well, I'm looking at the x part of it, which is 0. And then obviously you're going to look here at negative 1/2. And then obviously you're going to go all the way through the circle to find these values. Okay? You are going to go through the circle to find these values. So find only the cosine. So that's going to help you find the value for the points on that unit circle. Okay? How is that helpful? Well, that's going to help me graph, because I have to come up with a table. You graph by coming up with a table. Okay, so here's a table. I see here myself looking at 0 again. So I have at 0 degrees, I have cosine of 1. So here's my 1. I put the 1 here. See that? Put the 1 here. Which goes here. And how about 90? Well, at 90, I have a cosine of 0. Well, that's 0. See that? That's 0 here. And if you kept on going, you're going to see that at 180, you've got negative 1. Here's exactly negative 1 for 180. And at 270, let me scoot this up a little bit. At 270, I will end up with cosine of 0 again. Here's a 0 for 270. Here's a 0. And how about back to 360? Well, that's not going to change because 360 is the same as 0. So you're going to end up with 1. So my brain is going, interesting. So I'm starting this graph of cosine at 1. And I am going down to 0. And I'm going down to negative 1. And then back to 0. And then back to 1. How do I graph that? Stay tuned. Stay tuned. Okay, so how do I graph that? Well, let's just follow the table. So from the unit circle, I went to the table. From the unit circle, it gives me the table gives me the graph. So now for 0, obviously remember the x-axis from last lecture, the x-axis is the degrees or the pi radians, remember that? And the y-axis is the values, 1, 2, 3. So I'm going to put 1 here. I'm going to put 1. I'm going to put 1 down, negative 1 down here. Negative 1. Okay? 1, negative 1. I'm just going to start plotting points. All what I'm doing is just plotting points. 0 is going to give me 1. So if you're at 0 degrees, you have to start with 1. Here's 0, 1. The second one is 90. So I'm going to go here and put 0 for 90. Okay, this is 90. 90 degrees, by the way. Or pi over 2. Don't forget that. Okay, and then for 180, I'm going to go to a negative 1. Ooh, down here. That's negative 1. Oh, my God. Oh, yeah, yeah. That's negative 1. 180. At 180, I'm at negative 1. This is 180, by the way. 180. Or pi. I'm all the way to negative 1. And then I go 270, I go to 0. 270, I go to 0. Sure. 270, I go to 0. Here's 0. And I'm going to put 270 to, let me put it maybe on top. 270. And which is 3 pi over 2. And finally, at 360, I am back to 1. 360. Why is this here? This is 2 pi. That was a mistake. At 360, I'm back to 1. Through 360, I'm back all the way to 1 over here. Okay, so how do I graph this graciously and kindly and curvily, if there's such a word? Whew! This is how you graph the cosine wave. It starts at 0, 1, goes all the way down to 0, negative 1. This is negative 1, by the way. This is guy named negative 1 here. Okay? and then goes up to 0 again, and then all the way to the 1 at 360. So I'm going to put 360 here, 360. Let me erase this x-axis here, or the 2 pi. So this is the shape of the cosine function. This is the way it looks like. You start at 0, 1, you go down to 0, down to -1, down back up to 0, and then all the way up to 1 again. This is the graph of the cosine function. Remember, the cosine function, if you looked at it closely, this is called the parent function. And from here, I'm going to choose a different color for this. So from this point all the way to this point, I've got the period. Remember, the period is how long does it take for the wave to start and finish. So this period is 2 pi's. The period for this is 2 pi's. All right? That's the period for the cosine. Now, you might ask me, Armani, come on. How did you know it's perfectly... let me go back here and talk about that for a second. How did you know it's perfect... let me go back here. How did you know it's perfectly... oh, come on. What did you just do? Cooperate, you think. Okay, so I'm going to go back here. Back here, pardon me. I'm trying to have this software cooperate. Back. How did you know it looks exactly like a curve? How come it's not just a line? Well, let me just get to my point here. I know this because I only took few points. I only took the 0, the 90, the 180, the 270, and the 360. But the fact of the matter is, you actually could make yourself a long table, right? You could make yourself a long table like this. I'm looking at 0. You could put 30, 45, 60, 90, 120, 180, 240, and you also could put some other points. Like, for example, I could put 35. I could put 43. I could put 94.6. Sure. So once you start plotting points, you will see that you will definitely end up with a curve-looking thing. It's not going to be a line. So again, you're going to start with 1, and you're going to go down to -1. That's your lowest point. And you will end up with something like this. And 2 pi. You will. Trust me. If you don't, that's okay. You just test it yourself. Fill this table with things that you like. Obviously, if you like, obviously, to use things on the unit circle, it's a little bit easier. Or if you like to use any angle you would think of, you will end up with this curve over here. This is a cosine wave. This is how you graph the cosine function. Okay? So obviously I've took some time to put this table here, which just an indication for you that you could do it yourself. You could come up with your own points, proving it to yourself that this line is curvy. This line is not just going to be a straight line. This will not be a straight line. I guarantee you. This here we're talking about will not be a straight line. It's not a linear. So there will be a curve. This thing is curved. Okay, and you could prove it again by picking points, any points you like, any angles you like, and fill that in. Okay, here we go. So this is what we just did a couple slides ago is the parent function. So the papa function for the cosine, or papa or mama function for the cosine, has these characteristics, okay? Has these unknown things about it, for example. So number 1, we know that the cosine reaches, or the parent that is, reaches all the way to 1. That's the maximum point. We also know that it could go down all to -1. Nothing below -1 for the parent. That's the bottom. That's the basement for the parent, and they cannot go below -1. They also cannot go above 1. That's the ceiling. Okay, so a couple other things here. The amplitude is 1, and you measure the amplitude from the midpoint. So if I were, let me graph this because we're going to talk about this just a little bit more. So the midpoint here, see this midpoint here? I put this midpoint here. The maximum that you could go up for the parent is 1. That's it. Can reach more than 1. The minimum you can go down here is -1. You cannot go beyond that as a parent. Children can. We're going to take a look at that in a few seconds. But parents, that's it. 1 at the top, -1 at the bottom. So that's why we say the amplitude is a distance, and distance is always positive. So from the midpoint, this is how you measure the amplitude. From the midpoint, you say, well, in this case, I have 1 up or 1 down. So the amplitude is going to be equal to 1. Okay? Period is how long does it take, again, for this function to start and finish the wave. Write the wave. Write the wave. So how long does it take? Well, if you look closely here, you will find yourself looking at 2 pi over here. You're going to end at 2 pi. So let me erase this dude here. You will end up this at 2 pi. See, from here to here, it's going to take 2 pi's. 2 pi radians. So the period for the parent is 2 pi. That's how long does it take from the beginning and finish of the wave. See that? Beginning and finish, it's going to take you 2 pi. 2 pi. Well, half as much as that. Half of 2 pi is how much? Well, that's actually going to be the pi, which is the 180. Half as much, the pi is how much? Pi over 2. That's the 90. Well, between pi and 2 pi, you have 270, which is 3 pi over 2. Over here, 3 pi over 2. Okay, so that's how you do that one. Also, don't forget that in the parent function, we know that the amplitude is 1, right? And we know the amplitude is 1. We know the pi. This is 2 pi, and we know it's going to look like this. Okay, 2 pi here. Okay, let's take a look at the domain. What can you put? Remember I said that a couple minutes ago? You could put any angle you like. You're not just bound by the 0, the 90, the nicer ones. You could put anything that you like. Any angle. Like 275.632. Sure. Put that in the calculator. You'll find a value, and you will land on this curve. Anyway, so that's why it's saying the domain is all possible real numbers. This double R means real numbers, by the way. Okay, x such as x belongs to or part of all possible real numbers. Now, how about range? We just talked about the range. Range is the y value. Remember the y-axis? So domain is looking left and right on the x-axis. Range is up and down the y-axis. How far can you go? How low can you do? So how far can I go down? It's -1. That's -1. That's what it says here, -1. And how high can you reach? Well, that's the 1. You could get the 1 from here. That's why it's your y, your domain, is bound between -1 and 1 as the parent. Don't forget, we're talking about the parent here. It's the parent. Who loves their parents? I love my parents. Okay, parents, take care of you, okay? Say thank you to your parents. Okay, period. The period is how long? We just said that the parent function takes 2 pi to start and finish their wave. And the amplitude is 1. We just also confirmed that because the amplitude is the distance from the midpoint up and the distance from the midpoint down. Distance, okay? Or sometimes said halfway through between the top and bottom. Okay, or the average between the top and bottom. But it's easier to think of it distance from the midpoint up, the maximum point, from the midpoint to the lowest or the minimum point. Okay, here we go. Now we're going to have some, these are some kids. Now I'm going to talk about the kids. So the parent can only reach 1 at the top, -1 at the bottom, and they have 2 pi's to start and finish their cycle. Okay? So first thing first is if I'm looking here at this dude, and let's say I am looking at the parent here. Okay, what's up with this parent? That's actually not a parent anymore. These are children now. These are kids. So look what I'm looking at here. So this A here is going to give me the vertical stretch. Okay, just again, just like with the rubber band, you take the rubber band and then you stretch it. You can really stretch it like this, vertically. You also could take something like a balloon and then you could compress it, right? You could compress it so it would be long, elongated like that. Hope, like this, okay? So you could, we call this as a vertical, either stretch or compression. We call that thing either the vertical, horizontal stretch, or horizontal shrink. Okay? So that's exactly what we're talking about. So the A tells you if you have a vertical stretch or compression. Vertical stretch or compression. And also, by the way, if you don't forget that the A also tells me the amplitude. How high can it reach? How low can it go? And remember, the parents do not have, they only have A equals 1. That's why the maximum they could reach is 1, and the lowest they could reach is -1. Now, how about if what if A is negative? Well, if A is negative, then what you need to do is you need to reflect over the x-axis. So, for example, if my function is here like this, and I have a negative, then it's going to be like this. So you got to reflect this, dude. You actually he's going to start down here. Start down here and look up like that. That's if you have a negative. If A is negative, that's what you do. If A is negative, that's exactly what's going to happen here. You're going to reflect. Now, what about the B? So we talked about the A being the helping out with the amplitude, and also compression, vertical compression or vertical stretch. Also, what about the B? What does the B do? Well, the B helps you find the horizontal and stretch or compression. The B helps me find the horizontal compression or stretch, which also helps me find the period, obviously, because if you're taking the function and then you're compressing it, that means compressing it horizontally, that means you're going to finish the cycle very fast. Your wave is going to start and finish very fast. And if you're taking your function and making it longer, like really wider this way, which is a horizontal stretch, that means it's going to take longer for the wave to start and finish. So it does affect, the B does affect the period, obviously, and also tells us the horizontal stretch or shrink. Okay, let's take a few examples on this. Here's a few examples on the kids. Here's some kids that I'm looking at here, and it says transformation of the parent function, the graph. Here is a first example here. So let's say this is A, for example, and this is B, this is C, this is D. Okay, for A, I have y equals 3 cosine x. What is the amplitude? They're asking me for the amplitude. Remember, the amplitude is the absolute value of the A. Well, since this is A equals the absolute value of 3, then your amplitude is going to be 3. That's how high can you go, how low can you reach. Basically, what they're saying is you're going to go all the way down 1 and 2 and 3. And from here, you're going to go like this. And 1 and 2 and 3. See that? You just stretch that wave. Okay, what about number 2? What's the amplitude for this guy here? Well, the amplitude for this guy here is going to be, once again, A equals, I'm going to answer that down here, A equals absolute value of -2 or just a 2. So you are going to do it like this, 1 and 2, 1 and 2, and then you're going to do like that. With one exception, you're going to be very careful here that this dude is what? This dude is negative. Oh my gosh. If it's negative, that means this has to be reflected. So instead of starting at the top, you're actually going to start here. I'm going to go all the way down here because of this negative thing. That negative is going to give you that yellow carreau. All right. Moving down. What about the period? Can you identify the period for these functions? Well, let's take a look. Let's take a look. I don't mind taking a look at this. So I'm going to take a look at this. So first of all, it says identify the period for, I'm going to use a different color for that guy. And let's say here. They wanted me to identify the period, and the period has, I need to highlight that for you because this is important. So if you're taking notes, make sure that you put that down for the period. The period for the function is, for the cosine and the sine, is 2 pi divided by the b, the absolute value of b. So make sure you have that formula down. So here's the first example. It says here, what is the period for this here? Y equals -3 cosine 2. Well, and let me use the period formula here. Period equals 2 pi divided by the 2. The 2 is going to cancel. The 2 is going to be simplified. I'm going to just end up with just the pi itself. What does that mean? Well, this means that you will start and finish your wave in only 1 pi, not 2 pi's as the parent. This gal is fast. She is fast. So if she starts the, here's 1 and 2, actually and 3 in this case, and 1 and 2 and 3. She starts here and finishes in 1 pi. So if she starts here at 3, actually I'm going to start at -3 because of this guy. So I'm going to start here -3 at the bottom. -3 go up and then go down. However, which is very important for you to understand, that this distance, this period, is going to be only 1 pi for this child. It's only going to be 1 pi for this child. Why? Well, you just found out the period on different color here. The period here, you found out the period from this formula here. Your period is 1 pi. So guess what? She is twice as fast as the parent. She's going to start and finish the wave quick. I mean, it takes her less time, obviously, to finish the wave than the parent. Let's say if this is a job, for this example that you're doing or something, and your parent takes 2 hours to do the job, you're going to take only 1 hour to do the same job. Okay? So because you finish faster. How about this dude down here? What is the period if the b is 6? Well, again, I'm going to use the period formula up here. The period equals 2 pi divided by the absolute value of b. In my case, it's 2 pi divided by 6, which is 1 over 3. 1 over 3, or pi over 3. Okay, pi over 3. Now, this is a little bit interesting. Pi over 3 means 60 degrees. This guy here, or gal, is actually very fast. This guy's very fast. So if I were to graph this dude here, I'm going to say they're going to start here. And this guy's going to start at his 1 and 2. He's 1 and -2. And we're going to start actually at 2, 0, 2. So all the way at the top here. All the way at the top here. And then we're going to go down here because this is the wave for the cosine. And then we're going to finish. However, if I'm very careful, I will have to notice something. What is that something, Armani? Well, that something tells you that you are going to finish your wave, your cycle, in pi over 3. The distance from here to here is going to be pi over 3. What does that mean? Well, that's only... How much is pi over 3? Can you tell me that in the comments? How much pi over 3? Come on. I take 180 and divide that into, slice it into 3 parts. 180 is a half circle. Divide into 3 parts, that's 60. So this guy here finishes the job in 60 degrees. Oh, ma. So the parents take, talk about the parents. If there's a parent here, you're going to take, oh my gosh. Takes 2 pi for the parents to finish. This dude starts and finishes in 60 degrees. That's a short time. That's what the B helps you with. Find the period for that function. Here's an example. We're gonna most likely we're gonna conclude with this. This says use the cosine parent as a guide. Graph this following function here. So h of x is 1/3 cosine 2x. Identify the amplitude and period. So first thing first, I need to identify the amplitude. So a for the amplitude is going to be the absolute value. I should say the absolute value is amplitude. Amplitude is the absolute value of a. In our case, it's the absolute value of 1/3, which is 1/3. What does that tell me? Well, this tells you right off the bat that the maximum that you could reach is 1/3. The minimum that you could get to is negative 1/3. That's exactly what this means. Second item is the period. How do you get the period? Well, you identify the period by using that little cute formula that I gave you. Come on! Which is 2 pi divided by the absolute value of b. And in our case, 2 pi divided by, what's the absolute value of b? What is my b? Well, this is ub here. That's ub, and that's the a. So divide by 2, and you could use your fruit ninja, and then start to chop, and you will end up with just a pi. Are you serious? Yes, I am very serious. Meaning, this child will take 1 pi only to start and finish. Not 2 pi's like the parents. Only 1 pi. You give them the job, it does it in half as much time as the parent. That's good. However, that child is 1/3 as the parent's height. So a short child, but hey, he does the job and faster. So I guess sometimes these things do not really matter as long as we are doing our jobs, right? Okay, so that's going to be this dude here. Here's it nicely written down. Okay, the second item is how to graph that. Well, I graph that by thinking. What am I thinking of? Well, I'm thinking of graphing a cosine. So how do I graph a cosine that looks like this? How do you graph a cosine that has, we just did actually last, I'm going to start at 1/3, ooh, down to negative 1/3, ooh, okay? And that's the maximum I could reach. I could start here, or go down here, go up here again. Remember this guy, we just said it's, how much was this guy again? How much was this guy? In 1 pi only, 1 pi. Oh my gosh, that is fast. 1 pi to finish the job. This would be a pi over 2. This would be pi over 4, obviously, right? And this would be, how much is this be? Between 90 and 180. That's 135, which is how much? 3 of the pi over 4s. Okay, you could put 180, I'm sorry. You could put degrees as well, okay? 180. You could put 135. You could put 90. You could put 45. Okay, remember again, faster, very fast. So the parent would be waiting very fast. Okay, it should look like this. This is beautiful and good looking, just like that. See that here? Start and finish of the start and finish, start and finish in 1 pi. See that? 1 pi for the cycle. Okay. Here's a quiz, last thing that we give you is a quiz. Use f of x cosine as the guide or parent. Graph g of x is 1.5 cosine 2x. And my thought here is for you definitely to pause because I'm going to put the answers momentarily, but you need to pause here. Think, where's the a, where's the b? I know the parent looks like this. Start from the top all the way here, and it's going to take 2 pi's for the parents. But this is a child, so is it going to be the same height, same amplitude? Is it compressed? Is it stretched vertically? And also the b. B tells me how long does it take, the period. How long does it take for the wave? And apparently here, x is not just by itself. There's a 2, number 2 there, so that's going to change the period. Is that child faster, meaning shrunk like this, or is it really slow to finish the wave, so it's going to take longer time? Okay, and the answers are here. So it should look like that when you graph it. Make sure you put the amplitude, the period, and tell me if it's stretched, shrunk, and stuff like that. Okay, here we go. Last minute. 1 minute of hope with Armani. Okay, we're down to the last very few days here. If you are obviously somewhere studying, but if you're watching this afterwards, well, that's good. So my points of hope today is, again, is not just looking inside, because sometimes you can't just find help inside here. You have to look outside. And I'm not talking about people, because people disappoint you sometimes. And I've been there, I've done that, and I've been on both sides of the equation. So we have to look up. And when we look up, we find our help. And I think each one of us would need a dosage of hope these times. So we need a stimulus package of hope and faith. Okay? So we're going to pray for that, and God is going to help us through this, of these uncertainties, a lot of it that is around us, and we are going to have, we're going to pass this, okay, guys? I admire what you're doing, taking care of yourselves, and take care of your families, and don't ever forget there's hope, and don't ask before you give. Always give. That's going to give you actually more hope, and gives you a good feeling. Give before you take, okay? And be blessed. It's been an awesome time with you guys here. Love you all. Take care of yourselves, and God bless you. Bye-bye.